Okay, so continuing our work on quadratics, we've previously looked at quadratics in the form of this: y equals ax squared plus bx plus c. And we had a look at that in previous videos, but I want to show you a different way that we can write the equation of a quadratic. And it looks like this. So we could rewrite any quadratic in this form: y equals x minus a squared plus b. Okay? So we could write a quadratic in this form. Now, why is that useful? It looks a bit funny. We've got x minus a here, squared. You might think this is a slightly more natural way to write it. But I'm going to show you why this is useful. It's useful for finding the turning point, because I'm going to tell you right now what the turning point of this equation is. The turning point of this equation is AB. So let's do an example. So suppose I've got the equation y equals x minus 5 squared plus 10. Okay, what does that look like if I plotted that graph? So let's draw a sketch. The turning point of this graph is the point 5, 10. Do you see I'm just reading this off? The A is 5, the B is 10. So this point here is the turning point. And I'm just left asking myself, what is it a positive is it a positive coefficient for x squared, or is it a negative? In other words, is it a U shape or is it a V shape? Well, in this case, we're going to end up with a positive x squared. So this is going to be a U-shaped graph. Okay, and straight away we know the turning point is 5, 10. We can have it in different forms as well. So let's consider a sort of N shape. Let's do a y equals negative x take 10 squared plus 11. What's the turning point of this graph? Well, our A is going to be 10 and our B is going to be 11. So again, we can sketch this graph. Okay, 10, 11 is going to be where it changes direction, the turning point where it turns around. But because it's a negative x squared, because it's a negative here, we're going to have something like this. Okay, so we'll have a wee look at a couple of different examples on the computer system. Okay, so here we have the parabola y equals x minus 6 squared plus 9. So what is the value of a? The value of a is 6. And what is the value of b? The value of b is 9. And so the turning point is 6, 9. So I'm hoping you can see why it's useful to write the equation in this way. It's useful because we can find this turning point very, very easily. Okay, let's play around with it. Let's change it. If I make that x take 4 squared plus 10, see how it shifts. That shifts the turning point to 4, 10. X minus 4, 4 plus 10, 10. Now be careful here, because we need to think about what happens when we add instead of take. So let's do x plus 7. So here we've got the parabola x plus 7 squared plus 10. Notice that the turning point is negative 7. And again, this comes back to this sort of standard form for thinking of the quadratic is x minus a. It's x take away a. So if you have a positive in here, what that means is you're going to end up with a negative on the x axis. So it's negative 7, 10 is the turning point. So it's something to be aware of. Really, what's happening here is this 7 is telling you how many steps to the left the turning point is from the origin. So that's plus 7, so we're going to go 7 in this direction, which is here on this axis, and then add 10. The B is telling us how far up we go. Okay, so let's just try a different one. Let's make it plus 5. and let's make a subtraction here. We'll make b -5. So let's have a think. Imagine where it's going to move to when I click enter. Okay, so a in this case is -5, and b in this case is also -5. So this is the point -5, -5. Okay, we can see that there. Now, as we saw previously, it's not just U-shaped graphs we can get. If there's a negative in front of the bracket, yes, I'll move that to make it clearer. Here you can see there's a negative in front of the bracket. If that's the case, all that's going to change is whether it's a U-shape or a N-shaped graph. And in this case, because it's got a negative, it's going to be a N-shaped graph. Notice that the turning point doesn't change. Okay, the only difference between those two graphs is whether it's a maximum or whether it's a minimum turning point. Okay, so it's just a reflection there. Okay, so I think it's probably worth having a look at a couple of questions. So here's one of the questions. Below is a diagram showing part of the parabola in the form, and again you'll see that it's in this form here. The maximum turning point is -4, 6, and that's shown in the diagram. And it says, what is the value of b? In other words, what would this be? In the equation of this parabola, what would we write in place of b? Okay, so b is telling us about the y-axis, and in that case it's 6. This would be 6. Okay, so I believe I wrote 6 in there. Let's check that, and that is correct. Okay, so the next question, we are given a parabola in this form, and we've also got a turning point noted on the question here is 9, 7. Okay, so let's find the value of a. Okay, so a in this case, x take a, so this is the form that we're interested in, and a we can see is going to be 9, because remember a would be 9 and b would be 7. So a equals 9. Yeah, a few red herrings there, but let's check that we're correct, and in fact we are. Next question. Below is a diagram showing several parts, showing part of a parabola in the form y equals -x take a squared plus b. Notice the negative, and that explains why we've got an N shape. Several points are marked. What is the equation of this curve? Okay, so we've got a few different options. First thing to note is A and B are the roots, and so we're not interested in those. C is the y-intercept, and we're not interested. A, B, and C are not relevant to us. D is the turning point, and D is what we care about. 36 is going to be what B is. So let's have a look at our answers. There's only 2 possible answers here that we're interested in, plus 36. And the only question now is it plus 2 or minus 2? Well, let's have a look. If it was minus 2, that would suggest that the turning point was somewhere here, where x was 2. So it's going to be this one here. It's going to be x plus 2 squared plus 36, because the 36 is telling us this, and the 2 is telling us that this is a -2. And again, if we check that's correct, we'll see that we're right there. Okay. Okay, final question. Below is a diagram showing part of a parabola in the form ax plus a squared plus b. Now this is a bit tricky because this says x plus a rather than x minus a, so we're going to have to be a bit careful with this. The minimum turning point is 2, -3, and that's shown in the diagram. So we can see the minimum turning point there. Find the value of a. Okay, Okay, so if I bring up the my webcam here so you can see what I'm doing, I think it's going to be useful to try and write down the equation of this graph first and actually just work this out for ourselves. So let's have a look. We've got the minimum point is 2, -3. That's given to us in the question. And we know that the equation of a quadratic is y equals x minus a, where this is a, squared, plus b, where this is b. So the equation of this line is x minus 2 squared minus 3. Okay, now this question that we can see here is, what is the value of a if we're looking at a slightly different equation, if we're looking at x plus a squared plus b? So in this case, b would still be minus 3, but let's have a think about what a would have to be. In this case, because we're saying plus a, it's going to have to be this whole thing here. It's going to have to be -2. And so our answer is going to be, if I scroll down to let me do it, it's going to be -2. Typed it incorrectly. Yeah. And you can see here there's a warning, be careful. We've been given the equation in the form y equals x plus a instead of x minus a. So that's going to change our answer. Okay. Okay. And that concludes everything on quadratics. Remember, this is the equation that you're going to need to learn. Y equals x take a squared plus b, where a and b are the turning point. So you can quite easily go from an equation to a sketch, or from a sketch of an equation to writing it out quite easily. As long as you know the turning point, or as long as you've got this equation, you can go from one to the other, backwards and forwards.